Hello everyone. Today we will study one of the most important machine learning concept, which is the confusion matrix. Okay, and we will derive the evaluation metrics like accuracy, precision, recall, and F1 score. So this topic is very important and it is often asked in interviews, and it is very useful in uh, real machine learning projects, specifically when the data is imbalanced. Okay, so let's start. So to understand the confusion matrix, let us assume a binary classification problem. Okay, binary classification problem. So it means that we have either yes or no. So like there are several examples in which we have binary classification problem. Like the first is email spam detection. Second could be your disease prediction. Okay, or maybe the fraud detection. Okay, and in this binary classification problem, we have only two classes. Okay, either yes or no, or maybe positive, which can be labeled as yes or one, or negative, which can be labeled as no or zero. Okay, so our model can predict either yes or no, and we will compare it with the actual outputs. Okay, so let us understand the confusion matrix with the help of a table. So let's say here we have the predicted class labels, and here we have actual class labels. This could be yes, no, and predicted also could be yes or no. Okay, so it should be here. Okay, now if your prediction is yes and actual is also yes, then it is true positive. If your prediction is no and actual is yes, it means it is false negative. If your actual is no and you have predicted yes, so it is false positive. And if you have predicted no and actually also it is no, then it is true negative. Okay, so true positive means model predicts yes and actual output is yes. Okay, whereas false positive is model predicts yes and actual output is no. Similarly, the false negative is your model predicts no and your actual output is yes. Okay, and finally true negative, your model predicts no and actual output is also no. Okay, so every machine learning evaluation matrix comes only from these 4 values. Okay. Now let us take an example. Assume that we have 100 samples. Okay. So out of these 100 samples, we have actual positives are 40 and actual negatives are 60. Okay. And your model predicts true positive, let's say 30, false negative 10, false positive 15, and let's say true negative to 45. Okay. So these values are predicted by the model. Now we will compute all metrics using this example. Okay. So the first quantity that we will use is the accuracy. Okay. So accuracy means that how many predictions were correct overall. Okay. How many predictions were correct. Okay. So mathematically it can be expressed as correct predictions divided by total predictions. Okay. Or it can be written as true positive plus true negatives divided by total predictions, means true positive plus false positive plus true negative plus false negative. Okay. Now if we will put the values from the model predictions in this expression, we will get accuracy as 30 plus 45 divided by total predictions 100, which is equal to 75 by 100 or 75%. So our accuracy is 75%. Okay. Similarly, the next quantity that we would like to evaluate is precision. Okay. So it answers that out of all predicted positive, how many were actually positive. Okay. So basically it is expressed as true positive divided by true positive plus false positive. Okay. And if we will put the values of these quantities, so true positives were 30. Okay. And false positives were 15. So it is 30 divided by 45, which is 6, 9, 2 by 3. It is equal to 0.67. So roughly 67%. Okay. So only 67% of positive predictions were correct. Okay. Now the next quantity that we would like to evaluate is recall. So it answers that out of all actual positives, out of all actual positives, how many did we correctly detected? Correctly detected. Okay. So it can be expressed as true positive divided by true positive plus false negative. Okay, so true positives were 30 and false positives were 10. So it is 30 by 40, which is 3 by 4. It is roughly 0.75 or 75%. So it means that 75% of real positives were detected. Okay. Now we have one derived quantity which is F1 score. Okay. Now this is derived from precision and recall. So it is a harmonic mean of precision and recall, and it combines both of them. Okay. So it can be expressed as 2 divided by 1 over precision plus 1 over recall. Okay. Now if we will use the formulas for precision and recall, which were true positive divided by true positive plus false positive, and recall was true positive divided by true positive plus false negative. If we will use these values, okay, or these formulas in the F1 expression, okay, we will get F1 equal to 2 times true positive divided by 2 times true positive plus false positive plus false negative. Now let us put the values here. 2 times 30 divided by 2 times 30 plus false positives were 50 and false negative were 10. So it is 60 divided by 60 plus 25, which is 60 divided by 85. So 5, 12, 12 by 17. So it is roughly 0.7. Okay. So it gives a more balanced evaluation. Okay. So we have seen that our precision was 67%, recall was 75%, and it is somewhat in between of both precision and recall. Okay. So the main issue is why accuracy fails. Why accuracy fails. So let us say we have imbalanced data set in which 99% are the negatives and only 1% are positives. Okay. So your model will predict all negatives. Okay. And its accuracy could be 99% because negatives are the majority class and positives are the minority class. So your accuracy would be 99%. Okay. But in that case, your recall will be 0. Okay. So then this model will be useless despite of the fact that it will give you high accuracy. So that is why confusion matrix based uh, metrics are important in real machine learning tasks. So I hope you like this video. Thanks for watching.